In this section, we want to talk about plane curves and parametric equations. Now, it's nothing to get too excited about or too upset about. It's just a different way of looking at how we express our curves, how we express the equations for them. Now, in the past, we've spent a lot of time talking about functions. And when we do functions, it's usually of this form. F of x is equal to, and then it's some kind of expression in terms of x. And this is great for functions. It's great for things that pass the vertical line test. But as we've seen, not everything passes the vertical line test. In this section, we've seen sideways parabolas. We've seen ellipses. Just pretend that's an ellipse. Or we've seen hyperbolas. These guys cannot be expressed as functions, but they can be expressed in a different way because they are planar curves. They are curves that occur in the xy plane. And so that's the rub when it comes to parametric equations, is that we come up with two equations, one that represents how the x coordinate is formed, and another one that expresses how the y coordinate is formed. And so a lot of times you'll see things paired up like this. You'll see, say, x of t is equal to an expression, and then y of t is equal to an expression. And then they give you these parameters for t. They might say, oh, I want t to be less than or equal to 5 while being greater than or equal to 2. In other words, t is going to run from the value of 2 all the way up to 5 and everything in between. And so you might have something that says, x of t is going to be 3t and y of t is going to be, say, t minus 5. And all this together is going to form a parametric equation. So what you would do is that you would just plug in values of t and see what your corresponding x and y values are going to be. So the x values behave like this. It's just going to be multiplying times 3 as t increases. But the y values are going to be t minus 5. So that's really the main gist of it, right? So each x and y will be represented by its own function in terms of t. So let's look at the first example that we have. So if I say x equals 2t minus 3 and y equals negative t plus 1. So sometimes you'll see it written like this, like x equals and y equals. We could just as easily have said, x of t equals and y of t equals. It's kind of one and the same. Now, we use t here. And not that it's always going to mean this, but a lot of times t is representing time. And as we're going to see in some other videos, it's not just being able to graph a curve like we were seeing here, but it's about tracing the movement of a particle as it goes along this curve. And that's what those parametric equations tell you. That is, in other words, as time goes from 2 to 5, you can then trace its path along the plane curve, which is really kind of cool. But back here to this. If I were to look at this to try to figure out what's going on, it might be a good idea for me to come up with a t-table of values. Now, when you do this, it's not just going to be two columns. You have t, you have x of t, and you have y of t, how these guys are all going to relate. So because of what we have here with t starting at negative 2, it might be a good idea for us to just go and increment this by 1 all the way down to when t equals 3, and then find the corresponding x and y values. And it's the x and y values that are going to form our ordered pairs. So when we plug in negative 2 into here, it's 2 times negative 2 minus 3, so we get negative 7. And we plug negative 2 into here. So negative 2 is positive 2 plus 1 is 3. So that's our first ordered pair, negative 7, 3. If I plug in negative 1, I'm going to get negative 5. And because we have experience working with these linear equations, we start to see the pattern. Because my slope here is 2, I'm expecting this to increase by 2 for each increment that I have for t. So I know this is going to be negative 3, negative 1, 1, and 3. If you don't believe me, plug those in and you can verify that. If I plug in -1 up here, that's going to give me +2. And again, you pay attention to the sign, to the slope. That means each increment of t means we're going to be losing 1, so we'd be here at 1, 0, -1, and -2. And then we can take all this, put it together, and come up with an idea of our graph. Now, paying very close attention to the fact that t is going from -2 to 3, and it's bounded within those values, we're not going to be able to put arrows on the ends of these saying, oh, extends forever and it goes off the page. No, it starts when t equals -2, and it stops when t equals +3. All right, so let me just try to draw this real quick. And because I've got my graphing grid here, I'm going to go ahead and set up, there's my origin. We've got -7, +3. So here is -7 and +3. It's going to be that guy right there. Then we have -5, +2, -3, +1, -1, 0, 1, -1, and 3, -2. So this is going to be our graph. Okay, so keep in mind that we started right here and we finished at this ordered pair, right? So you could say, okay, we start here, let's say that's S, we finish here at F. And sometimes what you'll see on these graphs is that you will see an arrow on it indicating the direction of the movement. So we're starting from this point going all the way down to that point. There's that movement that we're doing. All right, so let's now take this and we're going to look at it in terms of what its rectangular form would be. And the rectangular form means you don't have this extra parameter of t, you're just writing it strictly in terms of x and y. So what we can do is that we can take one of these equations and solve it for t, and then just plug it into the other guy. So what I'm going to do is I'm going to take this guy right here, and if I solve this for t, we'll find that t is equal to 1 minus y. And so let's take that and substitute it into that value, or that variable t in the x equation. So then we'd have x is equal to 2 times t is 1 minus y. And then we have minus 3. And so we just work it out from here. Distribute. And then we can combine like terms. So negative 2y minus 1. Or from here you say, you know what, let's make this in terms of y, put it in slope-intercept form. So y is equal to negative 1/2 x minus 1/2. And you'll see that that does line up with what we have here in the picture. A y-intercept of, when x is 0, y is negative 1/2, and we have a slope of negative 1/2. And we saw that going here. So down 1/2 and all that. So this would be the rectangular form. But let's look at the graph. So bring up your graphing calculator, and you need to make sure that you are in the correct mode. So we were doing stuff before in polar mode. Let's go down here and change it from function to parametric. And if things ever seem off, always clear the memory before we begin these videos. So second, memory, and then press 7, 1, 2, and then go ahead and clear things out. So when I go to the y equals, you'll see that it has x1 and y1. There's a little t there because we know we're doing this in terms of t. And now we'll go to this variable button. If we press this button, we get x if we're in function mode, we get theta if we're in polar mode, and now we're going to get t because we're in parametric mode. So x is 2t minus 3, And then we have negative t plus 1. But let's go to the window. This is where you have to change your tmin and your tmax to match the parameters that are given to you right here as being from -2 to +3. So I want to go from -2 to +3. My t step. I tell you what, let's make this 1/100th. That way we'll be able to see, hopefully, because this calculator is kind of fast when it graphs, we'll be able to see the steps and we'll be able to see the path that it takes, matching up with what we have going from start to finish. The X-Men, I think all this is probably going to be good. And if it's not, we'll come back and change it. So let's graph. Okay, that was really too fast, right? What if I make this 1,000th? There we go. So you can see it tracing it out. And it starts all the way back here at the value that we had, -7.3, and it goes up to 3, -2. So that's parametric graphing for you. Now, it will get more complicated, but this is the main idea. And we're going to see a lot of applications with this here in just a moment.